Joe?
Thank you, Matt. And I appreciate everybody coming out, and appreciate that introduction before, Matt. I saw actually, he and John sent me the copy of the program before, and they actually had the word distinguished on there, and I knew Mark McCann didn't write that, so I figured it was John. And I knew my wife didn't write it either. In fact, I remember when my daughter was about 4 or 5 years old, somebody asked her, said, "What does your daddy do?" And she said, he's a doctor, but he can't help me. So that's where I'm hoping I can help y'all some today. And I just want to compliment Matt and John. That's as good a study. Y'all have got as good a database on fescue toxicosis and alkaloids infection is probably anywhere in the world on fescue. And I would encourage you to keep going and keep doing this. And in fact, I'm going to go into my professor mode here and things I've learned from teaching people. Basically, I'm trying to educate you today. I'm also trying to throw out some ideas, that we probably need to act on. So there are two things I always give my talks with, because I've learned this over the years. One is this quote from Samuel Johnson, if y'all remember him from even your high school literature class. He was a British essayist, very famous man, and he had a great saying that I think is so true. People need to be reminded much more than they need to be instructed. If you don't believe that, there's not a mother ever lived who didn't do this. I mean, how many times did your mother tell you to do something? She might have taught you one time, but she had to nag you 1,000 times. So you need to be reminded a lot more than you need to be instructed. So I'm going to do a lot of things here that are just reminding you of what you need to be doing. And in some ways, I'm going to be kind of like your mother. I'm going to tell you some things you don't want to hear, but you're going to begrudgingly probably say, "Yeah, well, he's got a point there, but I don't know if I'll do it." So anyhow, I know that going in, but we'll see what happens. The other one is, I think in any complex system, which grazing, livestock plant grazing systems are complex ecological things. They're really systems, a lot of interacting, a lot of loose parts moving together. So I like this quote by Jim Rohn that success is neither magical nor mysterious. Success is the natural consequence of consistently applying basic fundamentals. The greatest analogy I can show here is that if you go to a Little League baseball game and just go before the game and watch them warm up, they take infield, outfield, they're doing the fundamental things they've been taught to do. Bat practice, and you see coaches are coaching them. Just go immediately, if you could go immediately to a professional game, Baltimore Orioles or Atlanta Braves, get there before the game, what are they doing? Same thing. They're reinforcing fundamental skills. They never stop. Even the best ball players in the world do that. And so I think you always need to have those fundamentals, those fundamental principles of forage management in your mind, and then you can attack those fundamentals as much as you can. I tell you, I learned that from Roy Blazer. I've been around long enough to have met Roy and interacted with him a lot in my early career. And Roy, if anybody knew Roy, you know he wasn't shy about telling you something. And if you were out in the farm, it could get rough out there. But Roy always went back to a fundamental principle and then went forward from there. So now I'm gonna kind of bring you up to date of where we've been and where we're going with fescue. So how did we get here? Well, we farmed a lot of land east of the Mississippi River, really, that really didn't need to be farmed. I mean, it needed to be farmed for those people then. They had to raise crops. They had to make a living there. But as far as the land itself, it was highly erodible land, especially in this area. And so what you had then was an overuse situation. And then when we had so many problems, the Dust Bowl in the west and all kind of water erosion. To give you an example, in my state of Georgia, if you know the state of Georgia, about halfway in the state, the town of Macon is there. In 1918, there were 8.5 million acres of cotton north of Macon. 8.5 million acres. So when it rained, the rivers ran red, you know, and it eroded a lot of land, and I'm certain it was true all through, you know, the Appalachian Mountains. And so what the Soil Conservation Service did was cover this land. I go back into where I lived in Oklahoma for a while. I mean, the Dust Bowl was horrible. But you go out there now, they've revegetated a lot of things. So they revegetated with trees and grass, and the SCS did a great job doing this, and now it's called NRCS, but they restored a lot of land, and that was their mission. The revegetation, and we'll see in a minute, coincided with the release and promotion of a grass called Kentucky 31 Tall Fescue. And remember now, I have a tendency myself to condemn Kentucky 31. The rest of this talk, I'm going to really be talking it down, but it did what it was supposed to do. It covered the land and it prevented gullies. And it did a wonderful job. It was only when farmers said, well, I got my land stabilized now, and what do I do with a bunch of grass? Well, what you do is, well, I just want to just mention to you that the history of this is actually where it was collected in Manatee County, Kentucky. Pretty sloping land there, but he apparently had established, this guy Suter had established some grass from Europe, you know, probably just put it out there, been there a long time. And this guy from the University of Kentucky called Ian Fergus went and collected a bunch of plants, and it was so persistent, they released it as Kentucky 31. He actually, that's when he collected in 1931, and I think it was actually released about 37, maybe in the early, you know, around World War II. And so that coincided with this mandate from the SCS. We got this grass, we got this mandate, we're going to start covering land, and this thing will do it. And it was easy to do. Farmers could sell seed to each other. They could harvest the seed, sell it to each other, and just boom, just exploded. And so what happened then, when we reached the peak of fescue, by 1973 then, from about World War II to 73, we have 40 million acres of mainly Kentucky 31 tall fescue. And you can see the dark areas where it's just almost wall to wall, the other areas, and then you got spots, you know, as you go west, it gets a little dry out there, except out in the, you know, on the Pacific side of Oregon and Washington. And so what you have then is that you had 40 million acres, so it covered a lot of land and covered a lot of sloping land, prevented erosion. But it also now, we got 40 million acres of a problem. What that was we started as farmers put livestock, I mean, what's the best use of grass? Put livestock on it. Well, it worked. It did work okay, but then their problems started happening. You can see, and these are the worst. These are the worst ones. Most of the time, it's just what's called summer slump. We'll talk about it later. They're just trying to cool themselves off. You know, they're just not great. You know, so they end up not performing as well as they could. But you know, some of the numbers that people are throwing out there, it looks like, you know, back in 2004, and that was probably an underestimate by Freeberg and Waller at the University of Tennessee, about $600 million a year. Even using that in the fescue belt, probably costing you about $79 a head, and that was a few years ago. I estimated that. You know, and I'm not an economist, but I can tell you, I can act like one, because you know what the difference between an economist and a dog at your back door? If you let the dog in, he'll quit whining. So I can whine with the best of them. So you just say that number, I'll stick to it, and I'll just whine about it. It's costing a lot of money, though, for sure. And of course, it was, as Matt mentioned, it was during this time that we started saying, well, what's causing this problem? We looked at a lot of things, and we went down some blind alleys for sure. But then finally a guy, he was at Athens, Georgia, a guy named Charles Bacon, and there was some work being done in New Zealand at the same time with perennial ryegrass. We were starting to say, find out that there's a fungus that lives inside this plant that, you know, what we found out is just almost, you know, it's almost serendipity how they found out. They had some pastures at Auburn University that they didn't know were not infected, and the animals, they had 2 pastures, the animals were performing great over here, and over here they weren't performing well, and they went in there and they knew of Bacon's work, and they got Bacon to come look at that stuff, Charles Bacon, and he found that the ones that were doing real well, for some reason, didn't have the fungus. But yet they came from the same, they were Kentucky 31. And what they found was they had stored the seed wrong, and it killed the fungus, and actually it was the first source of fungus-free grass that they had. And when they compared the two, they said, oh man. And so this is that fungus. It's called Neotyphodium cynoephialum, for anybody that likes taxonomy, fungal taxonomy. But it's a fascinating organism. And we could talk all day just on the mutual. It's called a mutualism. These 2 organisms mutually derive some benefit from each other. So the fungus lives in there. It loves it. Got a nice host. In fact, it's actually turned its whole life cycle over to the plant. You know, most of the disease fungi that we look at for cereals and stuff, you know, they have to come out, form a reproductive body like a spores, and then they spread those spores and more plants get infected. This plant just lives in there, doesn't even have a reproductive cycle. It perpetuates itself by going into the seed, and then the seed's replanted, and that's how so it's a very fascinating thing. But just know that this is what they found out, though, that this fungus was directly responsible, when it's with the plant, to doing things that we call producing a lot of alkaloids, but the main ones that we worry about is the ones that affect livestock, and that is the ergot alkaloids. They think that it's a group of alkaloids where probably the main problem, even though there's still some debate on that. So that's one reason I'm going to be using these things interchangeably, ergot alkaloids and ergovaline, but just know that they're just interchangeable right now in my view, because the highest percentage is ergovaline. And whether it's still the main thing, I don't know. But we've just decided to do all the ergots because there's several others in there. And ergot bodies are, you've probably heard about them, they can cause all kinds of problems in humans too. If you eat ergotized rye, you know, if you've heard about people eating ergotized rye, they get, well, it gets them all hepped up, because actually that ring is the LSD compound. So they can get, in fact, they think how Shakers and Quakers got their name was that they were eating a lot of ergotized rye, and then when they get in a religious stirpa, they'd fall on the ground and shake and quake. You know, so it's all kind of things going on here, but in fact, Timothy Leary, I think, I'm not sure about this, but I think he actually isolated the first LSD compounds from ergot bodies from rye, from cereal rye. But anyhow, it's a common compound, and it does produce some pretty good, as Matt showed you. You know, you say parts per billion, that doesn't sound like a lot, but that's a lot. When he's had some up there around 7,000. I mean, I did a lot of sampling. That is screaming. I don't know how they got the animals up and walked up, you know, could get them across the pasture. Mark, we had some animals we couldn't even get up with that kind of thing back in Georgia. And of course, I borrowed this slide from Matt. You know, they know it's a blood vessel constrictor. There's a lot of other things it does, and so, you know, is when you get that kind of constriction, you can have fescue foot. And of course, the main thing is they can't cool themselves off too. They tend. This is a more common problem. This is fairly unusual. Those big problems, I threw it out there to everybody get upset, but this is more common. You know, it's just a hot day, and you talk to farmers, and they, you know, we're all human beings, and we tend to rationalize. You know, we're great rationalists, and we can talk ourselves into anything. Is the best example I can give of that is that I was telling Chris this story last night. The best example I ever heard of that was two very educated people sitting at the same table, and in front of them was a bowl of fruit. And they're talking, and, oh yeah, look at this fruit. This is really pretty, isn't it? Yeah. So one of them picks up a green pear. And he starts looking at it. He said, "This is a nice green pear." And he said, "Yeah." And he flips it around, a little yellow spot on that pear. And he says, "Look at that. That's a yellow spot. This might not be a green pear. It might just be a yellow pear that hadn't ripened yet." And the guy said, "Yeah, that's you're probably right." So he keeps talking, and then he keeps flipping that fruit, and he says, "You know, that's got an oblong shape. It doesn't really have a good pear shape, does it? It's kind of oblong in it." And he said, "You know, I think you're right. I think that does have an oblong shape." So they keep talking, and after a while he says, "You know, if that's an oblong shaped fruit and it's yellow, that might not be a pear. It might be a banana." And the guy said, "I believe you're right. That's a banana." So in a very logical and rational fashion, they just made a banana out of a green pear. And we do that a lot, don't we, as human beings? We come out and we see this, and we say, "It's a hot day, I'd be in the pond too." Well, that's only partially the reason they're in the pond. Most of the time they're in there to cool off because they can't dissipate heat. They've constricted their blood vessels, they can't dissipate heat. So it's building up a thermal problem for them. And then finally, you can get depressed prolactin levels. This is a very sensitive way to look at toxicity. I'll talk about it later. Again, I'm not an animal scientist. Mark's in there. I always have Mark to keep me straight. But I did stay at a Holiday Inn Express last night, so I can talk. But this is a little hard to see, but basically if you have a fungus-free, the blue and the green is a max Q, you can see blood prolactin levels crash within days, really. I mean, it just boom. If they get, and it doesn't take 7,000. I mean, we're talking about just a few hundred, and it's starting to crash. So the first symptoms are starting to show at very low levels, and then by the time you get to higher levels, then it's starting to affect the animals themselves. They're starting to stay in the ponds. They're not grazing. They're definitely not gaining, and they can, you know, if their exposure goes a long way, it can lead to real problems. So what was the answer historically? Getting back to the history here, just take the fungus out, and it worked. It still works. We have less problems. Fungus-free is 0 alkaloids. You got to have the fungus with the plant to produce the alkaloid. The plant alone, or the fungus alone actually, doesn't produce alkaloids as good. Well, the plant's not at all. And the fungus, it has to have that fungus with it doing it. Well, that all worked real good until we started putting it out in dry weather. And I tell you, it created a whole new species from what the farmers were used to. They had 40 million acres of a species that was tough as nails. And I tell everybody, they had Superman, and we created Clark Kent, you know, and they didn't really like that. They just didn't like it. And so it has some use still, but people wanted to have something similar to what they've always had. But, you know, when we removed the fungus, it really reduced its persistence and the performance that farmers were used to. So that only worked for a while. And I just real quickly, why do the endophytes make it more persistent? Some of it's just mechanical. You actually have reduced grazing. I mean, they're not grazing as much. There's a tendency then to go with a lot of biomass, if you would, into the summer. And when you go do that, that tends to, the sun can't get onto the soil surface. It tends to build up, you know, and allow it to go over the summer a lot easier, because it's nothing competing with it, and it's also insulating itself in some ways from really high temperature that really results when you open the soil up. So that's one thing it does. You just get. In fact, I remember, Mark, we couldn't, some pastures we couldn't stock heavy enough to make them eat. It just kept building up. We kept putting animals out there, and they still kept building up. But yet you get into a fungus-free pasture. It's probably one reason it's not very persistent too. We even worry about it in somewhat max Q pasture. They're consuming it. I mean, they're really grazing it down, and you can't overgraze it. You know, you finally get in a situation what we've always hoped for, that we can actually overgraze fescue, but we don't want to, but it is possible. Also, all alkaloids are not bad. This same complex produces some other alkaloids that have beneficial effects. There's pyramine alkaloids, which have anti-insect properties. So there's a suite of alkaloids being produced by this thing, and you got to remember it's that mutualism is because the plant and the fungus derive something from each other. That fungus is trying to keep, since it doesn't have its own reproductive cycle, it's trying to keep that plant alive as long as it can. So it's helping it not be grazed by animals, not be hit by insects, probably not even diseases. In other words, it's got a lot of things going on. Some are beneficial to the plant. I mean, all are beneficial to the plant, but there are some that we actually want to keep in the plant. Also, endophytes also, again, they're trying to help this plant be as strong as it can. It actually, we found that it produces some plant growth hormones, just low levels, but will actually allow more tillering and more growth. And you can really see that when you take the fungus out and compare two plants that one has the fungus and one doesn't. You see that kind of effect a lot. Not all the time, but a lot. And then finally, it's probably still tied to this plant growth hormones, but we get more leaf rolling in infected plants during dry weather, and the infected plants tend to live over droughts better. So all these things go together, and it makes it very fit in nature. You want to know why there's 40 million acres? Because it's fit, and that endophyte is making it fit. So we had the classic dilemma at this stage. We had animal health problems, and we didn't like that. But we had pasture persistence problems, and we didn't like that either. So we were sitting there saying, what am I going to do? And it was about this time that they were talking about now in the late 70s through the early 80s, where there was a lot of work being done on this because they had defined it, and now they were trying to say, how could we get ourselves out of this? And of course, the universities, especially, this was their mandate, especially the experiment stations and the extension service. This was their mandate. We needed to do something to help farmers overcome this problem or somehow solve this dilemma. It's the classic horns of a dilemma. You got animals, you don't want them suffering, but at the same time you want to keep your pastures or make the management a lot easier on your pastures. So there's a lot of stuff out there now. I just showed two publications that came out of either national organizations, international organizations, or even and I'm sure Virginia's got them too. You can just find them. And there was a lot of research and extension efforts, and you can tell how to manage fescue. And so, just real quickly, what did we do? Well, what we were doing, and I want to start emphasizing this, we were just mitigating. We were just reducing the problem. We weren't attacking the problem. I mean, we weren't getting rid of the problem. We were just trying to manage our way around it, which is fine, and that's really where we are today. We're still trying to manage our way around it. And those management things fell into three categories: animal treatment, pasture management, and then finally where we went to in my program was trying to develop new cultivars and endophyte combinations that solved that problem. Gave us the animal health that we wanted, or the animal performance and no toxicity, but at the same time kept at least some level of persistence that the farmer was expecting. So let's look at the animal treatments. Again, these are rescue efforts mostly. They're treating the symptoms and not the problem. I want to emphasize that. The first one was there are some pharmacologic agents. Domperidone is one. In other words, especially in horses, when they're getting in they're really in severe, and they're pregnant mares, they're having to rescue them. They get them out of there, and they actually give them this so they will not abort their foals and stuff. I mean, this is truly a rescue effort. And then of course, feed supplements. I think Matt, that thing you showed was very interesting about the copper and the zinc. I mean, that's you can say selenium, copper. Some type of additives to help the animals along. Would be one way of doing it. The other one was breeding. I mean, there was a lot of work being done. Could we actually breed our way out of this? In other words, animals that had been exposed to fescue for a long time, did they actually Have they been adjusting, you know, genetically, et cetera, et cetera. And then finally, could we vaccinate them? Could we build up vaccines? And we found out we could. There were a lot of work. I don't know where it went, Chris, but there were a lot of vaccines being developed, and it just became, the clinical trials became very expensive, and I think they didn't, a lot of, like Merck, and then they just decided, well, or Pfizer, they might not could go there. So Mark, this is the classic animal science approach, isn't it? We're going to dose them, we're going to supplement them, we're going to breed them, and we're going to vaccinate them. If that doesn't work, then we're going to finally look at our pastures. Yeah. And so now we're going to get on to the agronomy. So again, pasture management, this is where we are today. If we want to go after it, from this standpoint, we're going to avoid it. This is a classic environment. We're going to avoid it. We're going to switch to just a different species. You don't like fescue, use orchard grass. I'm not sure I can do that. Or at least use some orchard grass hay or Bermuda hay or something when you're feeding hay. At least try to cut down how much they get exposed to. So there, you know, and it works. I mean, there's no doubt avoidance is a real good way to do it. Manage your endophyte-free. And there are farmers who do that. I mean, there are farmers who have just decided they're just going to do the things they have to do. They're going to pull animals off at the right time. They're not going to overgraze. They're going to keep their fertility good. And I've seen pastures of fungus-free fescue, even in Georgia, that are 10, 15 years old. You know, the farmers are just managing their way around. So just know that that's a possibility. The other was what Matt mentioned, interplanting with legumes. It's always been a debate, though, I think, among people who work in this area, how much is nutrition and how much is actual dilution. Even though Matt showed that when you have a grab sample, and I thought that was great, Matt, that when you have a grab sample of a mixed stand, your alkaloid levels are lower. But what that doesn't account for is selectivity by the animals. I don't know I don't know how much of that grab sample the animals are actually eating. Are they eating more clover or are they eating more grass? In other words, they actually might not. They actually might be taking in a lot more than 350 parts per billion. Or they might be taking less. It's just hard to tell. It's just you know, a wild card sitting out there. But there's no doubt. Even if you got fungus free or max Q, plant clover. It really helps. It'll really help, and especially in this day and time where nitrogen fertilizer is expensive. It's still plant legumes. You can't go wrong. But as far as the topic today, though, of toxicity, it's probably diluting some, but the problem is, like I say up there, you're treating the symptom. The grass that's still out there is toxic. Removing the seed heads, you know, we always thought that was good. After Matt's data, I'm not so sure. You know, it looked like they kind of spiked up there. But anyhow, most of the data I've seen there is still the alkaloid levels, even when they cut them off, you know, they're still dealing in the thousands. Now I'm going to talk about something that's near and dear to my heart because it attacked the underlying problem. In other words, we wanted to get something out there that at least when farmers were replacing all this 40 million acres, they would at least replace it with something that wasn't toxic but still performed well. So we took most of the plant breeders, like myself, we took 3 approaches. The first one was, well, maybe we can just develop more persistent fungus-free varieties. They just need, you know, they've just been relying on this fungus for so long, they've evolved with this fungus. So maybe we should just find some that, you know, that during breeding and selection we can make them more independent of the endophyte and still as persistent as when they have the endophyte. The other one was, let's just take, like Kentucky 31, and just through breeding, reduce that alkaloid level. And I'm going to talk a little bit more about this approach a little later because I can use it as a way to make a point. But both of these we tried, and we weren't quite as successful. I mean, that word distinguished, if I had to go with what I did in these 2 things, we wouldn't be having distinguished written on there, I can tell you for sure. But we just didn't make a lot of progress probably a better plant breeder could have, but for each one of these, but we hit a wall out there that we couldn't overcome. But the third approach was, and we were going to reinfect. They were finding endophytes all over the world that were in fescue. They were neotyphodium, but they did not produce the main alkaloids, the main ergot alkaloids. They were just natural mutants that for some reason, didn't need ergot alkaloids during their evolution. So they are called non-toxic. A zero level of ergot alkaloids. They also called novel or friendly endophytes. But the goal of the breeding project was remove the toxic alkaloids to zero level in the seed. We'll get back to that seed thing in a minute. Zero level in the seed, because that's going to be important. But retain the stand persistence. That was the goal, and by taking the old endophyte out, putting the new endophyte in, doing some more breeding and a little bit of magic, we would hopefully come up with a variety that would fit our needs. And it was a lot of work, but we got our endophytes actually from a group in New Zealand. They had a bunch of endophytes. That was an interesting story too in itself. But anyhow, I had found this guy in New Zealand, Gary Latch, who was doing a lot of work in perennial ryegrass. They had the same problem in perennial ryegrass, a little bit different problem, but different sets of alkaloids. And I saw him at a meeting in France, and I told him, I said, man, I've got varieties that need endophytes, but they're all toxic. He said, well, I got some endophytes that don't produce the ergot alkaloids. I said, I'll put my arm around him, and we walked out. I'd been let him go for a long time because and then I went down to New Zealand and actually infected a lot of my material with their endophytes. And actually what happened was we had a variety called Jesup that was a very tough variety, especially when infected. And it's a kind of a Kentucky 31 type. In fact, as far as we can tell, it's probably essentially derived from Kentucky 31. And we had one of their best strains from Ag Research in New Zealand called AR542. And that became Max Q. And so why Jesup? Well, this, I don't know if you can see it in the back, but that green is Jesup, and that's Kentucky 31, that's Trump. And in the tough areas of South Georgia, we can get it to survive. It's just a very tough variety over a wide geographic range. And when you introduce a variety in the first time, it's good to have one that's buffered across a lot of environments. And this one was. So that was one reason we selected it as the main host variety. And then these are the guys at Ag Research in New Zealand I was working with, and this is Latch right here. Great thing about this project is I got to go to New Zealand several times. That's really nice for a forage guy. It's kind of like, you remember that story where the guy said, is this heaven? He said, no, it's Iowa. Well, a forage guy goes down there and it's like, is this heaven? Said, no, this is New Zealand. So you'll just see great pastures, great climate, great people. It's really an interesting place. But we looked at a lot of their strains. I just got just 3 of them mentioned here. The main thing we were looking at then, when you compare E plus and E minus Jesup, was that the relative value, I just got it all relative, you wanted the high survival, but fungus-free, you wanted the low alkaloids. So we looked for strains that didn't produce the alkaloids, and just about all of them didn't. But we wanted something that nicked real well with our variety, that when we put it in our variety, it mimicked its natural endophyte. And so this 542 came as close. It's probably going to be hard to see this, but so you see a lot of grass here, and then by the number of weeds, that yellowing here, that's mostly weeds in that endophyte-free, and then this one had, so we saw this a lot. So that was the first thing we had to prove, that it was a good host, that it was transmitted through the seed at a high level, and that also when it was put out in the field and in tough environments, it would survive about as well as the E plus would. So that was the one step. That was one part of the process. The other one, and that became 542, then became Max Q. The other one was animal safety. And this got to be really cumbersome. And Mark McCann, I'd say, did all this work. I was just out there helping. Mark, we did the lamb trials, and I think you sheared a lot of lambs to get us out there, and went out to Texas and got them and everything. So, but this was a classic picture. So here are these lambs out here grazing. Just a fence, netted fence, and these are trying to cool themselves off. You know, it was a classic effect. But what we saw was, whatever we looked at, we would see things like blood prolactin. Again, this is just the one I showed you before. That max Q mimicked fungus-free and didn't respond like E+. That's what we wanted. So as we looked, then of course, you know, we had to step up into other animal groups. Well, this is just the gain itself. And you know, what you're seeing is the gain as far as per head per day was, you know, on these lambs, you know, was pretty dramatic. I mean, it was 50%, 60%, sometimes 100% better gains on fungus-free or max Q than it was on E+. So it was going right to the bottom line too. But this is, again, a safety trial, and we were just looking at things to make sure we didn't have toxicity, because that was the real problem with coming out with a novel endophyte, is that you're saying that it's not toxic. That's a pretty dramatic statement, and you better prove it's not, and not only just in lambs, but in cattle and in horses and goats, and, you know, whatever else you got to do. And that's one reason there was so much work done on it. Here's a cattle trial. If this was one person, Mark, that'd be you out there, I think. I didn't think you weren't out there that day. But anyhow, that's you can see this is one I just took. This was the E+ cattle, and then the next pasture over were the max Q cattle. Hot day, out there grazing. Others are hugging the thing, trying to cool themselves down. So again, even when we went to beef cattle, we had a good proof of concept. The gains, whether in spring of thing, but anywhere from, again, 50% to almost 100%. Better gains. And this was another one that Richard Watson, one of Mark's postdocs, was looking at too. We're able to monitor the body temperatures, and you can see on those toxic pastures, boy, those they couldn't, you know, they finally cooled themselves down to normal, and then, man, it'd just go, and it'd be all day long. They were just hot all day long, and yet the animals that were on max Q and on fungus-free, they were just running normal. So these are the kind of proof of concepts we had to do, animal safety trials, to get persistence that we wanted, but at the same time trying to remove. And again, we had some of the same information on horses and pregnant mares, etc. So, what's happened since then? When I went to Oklahoma, one of the main things we were looking at out there was to develop the same thing for that western zone that we had done for the eastern zone, and so we came out and developed a new variety called Texoma, and then they had a new endophyte that it was a little more robust endophyte, stayed in the seed better, you know, was more hardy, and it's a 584 was the strain, and so now there's a new product out called Texoma Max Q2, and it's really better for that western zone. But anywhere, it seems to be doing well about anywhere we're testing it, even in the east, even though we tested a lot in the east. But it definitely was designed for those lower rainfall zones, and it seems to have a little better. Texoma itself was selected in a very low rainfall zone, so it's a summer active Kentucky 31 type, but now there is a new one out there. So that's where we are. So I brought you up to speed from the, you know, early all the way to now. So the last part of this talk, I want to just say that we're dealing, I know what I'm doing now is that, I'll be honest with you, we can't, I thought I never would have gotten this business if I thought I would produce a variety that would double animal performance and nobody would use it. I mean, it never made any sense to me. You know, I mean, it's not data driven. It's not there's a cultural change that has to be made, or at least the farmers have got to get convinced that they've got a problem before they're going to make any changes. And So I actually I've retired now, and I'm kind of going around like the guy that repent. The end is near. So it's like everybody there's gonna be some people after they're gonna go home and say, well, who was talking out there? This old boy from Georgia, and he was as negative as anybody I've ever seen. I don't know why we got him over here. He made me feel bad. But I really know that we've got to have a message to everybody that sticks to you. And and I'm not saying, I understand it's not my money on the line. It's not my pastures on the line. The easiest thing is me to give a lot of advice. But let me just say that if you have the mentality that grass is grass, and I don't think I have a problem, so why take the risk of replacing my toxic fescue? I think you might need to, I'd like to switch that thought process to this one. What alkaloid levels are you willing to accept? Which ones are you willing to accept? How low? You got them. I mean, if Matt's survey's right, every one of you got them. So what about this? So let's look at alkaloids. It dawned on me the last few years that we look at a lot of things that y'all just, and he showed them. Protein, digestibility. Now we even have what's called RFQ, nice big number. You want it good. And we even base management off of it, and people. Why not alkaloid levels? If you get protein down around 7-8%, I mean, Mark, you're going to tell them better go buy some protein supplement, and they'd be wise to do it. If there's an energy problem, they need to have an energy supplement. So the whole thing is that I think we need to start, I'd like to bring the discussion myself from just infection and a general thing of fescue to alkaloids. What does your pasture have? If it's a mixed pasture, what does it actually have? And where is the threshold to where you need to do something? I think that's where we're going, John. We need to be going in that direction in the research and extension efforts. And again, Matt has done a great job of, you probably have one of the best databases here for doing something and thinking along those lines. Remember that time, remember back a few slides ago, you said, well, you said so much, boy, I don't know, I don't remember, but there was a slide there where I said we were trying to breed the normal toxic ones down to as low a level as we could, just through selection. We don't know what we were doing. There's a lot of breedings like that. We're just selecting, and we don't know what we're changing. We're just changing. We know we're changing one thing. We just don't know how we're getting there. So we had produced, again, we had Jesup fungus-free, and we had Jesup toxic. We also had one that we bred down through selection. So it was an infected Jesup, a subpopulation of the normal Jesup E+, and we had lowered the alkaloid levels 47%. One thing I want you to know is that though what we considered to be toxic in our trials was at the low level of what Matt was showing you. He was starting at 1,000. We even bred that down to less than 600 parts per billion of ergot alkaloids. And of course, we barely monitored. You're always going to get some little contamination out there when you're in pastures, especially just like Matt showed with some of the max Q pastures. You're not, it's the whole thing is that when you have 40 million acres, you're not going to get rid of it all. I mean, there's always going to be something. That's why I want to get the discussion of talking about levels of alkaloids. It's never going to actually be zero. But where do you want to start managing, and where do you want to start even replacing? Where are those levels? There was a paper in the Journal of Animal Science by a guy named Stam where he fed fescue seed. He was in Oregon. It was a really nice study, I thought, in the Animal Science department out there. And he found, now I've had to make, he was monitoring ergovaline, but this is about right. Let's just for argument's sake. So he was seeing that blood prolactin suppressed about there, less than 200. less than 200. He also found that he started seeing animal gain suppression starting to happen at around 400, a little less than 400. So we were above that, so what did our stuff look like? If we look at gain, we definitely, from E minus, we definitely have a reduction in gain, but still better than toxic. So, you know, it's showing what everybody deals with fescue. I get something out of it. In other words, my animals still gain something, but we're talking about 30% loss in gain here. And these prices today, that might be a lot of money. And of course, you can see we definitely have higher body temperatures, more like E+. And of course, the blood prolactin's crashed, it's gone. So even though we lowered it 50%, we had it around 600, we still were getting fescue toxicosis. We still were getting some better animal gains than the toxic, but we still, so that's why I'm saying, what level can you live with? Just to look at the agronomic side, we actually, but I don't know what ergot alkaloids are doing, because we probably were doing some other things too that we were reducing, but again, we hit the sweet spot, you know, kind of a midpoint. Wasn't quite as persistent, but better persistence than fungus-free. So again, we were still maintaining some level of persistence. We actually kept the yield pretty good on them. So, you know, that's why I'm saying this approach didn't turn out to be too good for an approach to get a variety out to farmers, but it did become a nice research tool for us to look at maybe what is the level of fescue toxicosis or alkaloid levels that we can live with. So getting back to that thing, that's one reason I'm saying we need to start thinking alkaloids, and we need better information of what these thresholds mean. Unfortunately, again, just like my story about the economists, I'm throwing a lot of numbers around and meshing things together, and I'm doing a lot of smoke and mirrors. But I just know that if you're starting to get into the thousands, that's not good. You want to be in the hundreds, for sure. I'm going to quote my old buddy Mark McCann. He sent me an email not too long ago, but this is where I think we need to be. He said, our cattle producers have stated they want more research done with fescue. In doing so, alkaloids need to be more of a parameter than infection level. Amen. Let's go home. Let's eat lunch and go home. I really think that's where we need to be. So let me just say, if I could challenge the researchers in the room and the extension people in the room, we need more research to establish accurate threshold levels. That's one reason Matt's database is so nice. He's just building, he can just keep adding to this database. You can start getting a lot of trends and combining this with weather and all kinds of stuff. When at the year, when are we going to have to, you know, really, if you're going to start mitigating to do it, then you need to know what you're doing. And I just would like to challenge the same group to say, maybe we need to make ergovaline or ergot alkaloids just part of a normal test. I mean, we get a test for protein and fiber and digestibility and RFQ. I know it's a little expensive now, but I think if you can get them to use it more and get it to be more of a routine thing, why not just, if you send a fescue sample in, a pasture sample, and you asking for everything else that, like Matt did, why not throw in ergovaline too? Why can't they give you ergovaline? I'd like for them to. I know it's easy for me to say, but that might be something we need to think about. At least I'd like to challenge the public people in the room to think along those lines. So what alkaloid levels are you willing to accept? I think the answer is you need to keep them as low as possible. Low, just keep, you're never going to get them to zero. But let's keep it as low as possible. So first of all, Matt's done a great job, but you probably need to know what are your levels now. If you weren't part of Matt's study, maybe need to get some information from that. You don't need to sample as much as they did, but just look at maybe sample it when Matt saw it was the highest and where he saw it was the lowest. And so where is yours? Where's your sample? I'm going to use the big R word here. And you can say, well, that old boy, he's got a variety and he helps Pennington seed, so he's just trying to sell seed. That's true. That's all true. I'm biased, I'll tell you. We are trying to sell seed. But at the same time, I didn't get into this business to sell seed. I got into this business to help farmers. And like I said, I never would have gotten in if I thought if I was doubling animal performance and I couldn't help farmers. So the only way I'm going to help y'all is if y'all buy seed and replace your toxic pastures. And you know, the whole thing too is that it's still very important. And I'll say this too: if you want to manage fungus-free, when you replace that, you can replace it with fungus-free. It's just not quite as tough. So you're going to have to do a lot better management. But come back with something that has 0 in the seed. You're going to have 40 million acres contaminating everything out there anyhow. All you can do is drive it down to as low as you can in your replacement strategy. And then, but there's the only thing you can control. You can't control 40 million acres, but you can control the seed. That seed, better, if it's 0, you're starting off better. You're not contributing to the problem. So that's one reason you just don't go out and buy any seed. You know, in other words, just say if somebody said, "Well, I think this is fungus free. I stored it in the barn." Well, maybe, maybe not. You probably need to get good certified seed. You know. The old saying that certified seed pays, it doesn't cost you. So I'm going to just finish up, just talk about some replacement things that I've been thinking about and we've been looking at. And so you got this very expensive product, but you want to get to this right here. And it's a big step. I'd like to look at my old buddy John Andre. In fact, he worked with Mark and I there at Georgia before he went on to glory at Clemson. But he's come up with some really nice ways to replace fescue without plowing. And there's some key steps. The first one is, and this is good that we're talking now, because if you're thinking about maybe trying to replace some toxic pastures, you have some time to go sample them. And you also have time this coming spring to make sure you keep the seed heads off of it. Because that's a source of seed. That's a source of toxic seed. And as we'll see in a minute, you know, if you could get them off that spring, by the time you come back, to plant in the late summer or early autumn, you'll probably be in better shape with that level of contamination. He found that he can spray glyphosate 4 to 6 weeks before planting, it'll not kill down. Respray glyphosate at planting, and then drill in max Q. No till. This is what it looked like for him at Clemson. This is a spray down. So you know there's some green stuff out there, and these kind of things, they happen. I don't know if you need to be as concerned about these occasional plants. I mean, it's not going to be a perfect situation. You're just trying to get it down as low as you can from the beginning. Now, he also had a tilled area. He was comparing tilled and no till. But this area now, you might want to go back and hand spray. That's going to cause you some problems. That's a big area. And so you're trying to, use again, this is before planting and then at planting, two sprays. He's had pretty good kill down and gotten rid of it. And then by not having any seed, the previous spring, he didn't have a seed bank out there. And this is what it looked like. That's the same area. That's the tilled area on the left, and this is his no-till area on the right. So he had good stands both ways, but he definitely had good stands in the no-till situation. So those of y'all who want to do something no-till on sloping land, you might could do something. Here's some common concerns when replacing toxic tall fescue. Will the stands revert back to toxic fescue? There's always going to be that pressure in nature. Again, 40 million acres. We've created an unbelievable contamination zone out there. So there's always going to be pressure in nature to revert back. What can you do? So what we do know is that you still will retain a high percentage of those non-toxic plants that you've planted. if you manage to keep vigorous plants, you want to keep your fertility, you want to do good fescue management. You want to fertilize at the right time, you want to pull animals off at the right time, you want to do the things that Virginia Tech has been telling you for years. Toxic seed are not present in the seed bank. That's why we're telling you to mow the heads off the previous spring. Because how long will that seed remain in the soil? We found that they can remain for about 15 to 18 months. So if you've mowed off those seed heads, those toxic heads in the spring, say you mowed them off in May. Well, see, the only seed that's out there are the ones that were the previous May. That's 12 months. Then you plant another 3 months, you're at about 15 months. So the seed bank has deteriorated. That's one reason that's really critical, that you try to keep the seed bank that previous spring as low as you can. So this is something you need to think about. I don't know how critical it'd be. This is, again, a great area, John, for more research, is if you skip that spring or didn't think about it, and all of a sudden now I just want to go do my spray, plant, what am I sacrificing here? What am I doing? Again, you're just trying to do things to minimize toxicity. So that's why preventing that seed formation, the spring and establishment year is very important. Can toxic seed be important from animals? Yep. Found out that you probably need, if you're moving animals from a toxic pasture to a non-toxic pasture, you probably need some clean out period. You need to be on something where you hem them up and give them some hay or something from something else, where you need at least 2 or 3 days. This was some work done by John, and he still had a few after a couple of days, but it went down to near zero as far as the clean out. And it's only an issue when they're grazing seed heads, or they've got hay that's got seed heads in it. But if you're gonna, it's always a good plan not to move from toxic pastures to non-toxic pastures. You can go the reverse, but not go that way. At least not without a clean out. And I love this picture. This was a big ring was out there in a hay bale. It just planted itself. So if you bring in toxic hay, you're just contributing, especially if you're feeding on the pasture. You're just planting toxic fescue now. So just know that you're going to have to try to do everything you can to minimize toxic plants going in there. So going back to the original thing I was asking you, what is this costing you? What can we live with? I think was the original charge that Matt gave me. With prices being this good, what are they costing you? If you can gain another 50 pounds or 100 pounds on an animal at these prices, I don't know how much it costs to replace, Chris. I guess we got all kind of numbers, but or to mitigate, or both. Hopefully both. If you're still not convinced, let me just say that you ought to try just something simple on your own farm. First of all, get your area sampled, and if it's hot, maybe just put you a fence and do that spray thing on about 5 or 10 acres where you can put 2 groups of animals in and just observe them. First of all, to give you some experience, on a small acreage, can I replace? What am I doing? In other words, I think it'd be worth it, and then you just keep looking at groups of animals and how they respond. You actually can, you can take some weight gains on them, I'm sure. Matt could probably even help you with. And then get some ergovaline samples and just see how low can you get them and then compare. So that's one thing you could do. But anyhow, again, my main message is toxic alkaloids are bad. In fact, I'm going to get into my preaching mode. They're evil. I'm fixing to get into evangelism now. They're evil. So you got to do everything you can. You're never going to get rid of all of them, but you need to get it where you can manage them and they're not managing you. Anyhow, I appreciate y'all coming out, listening to somebody from Georgia, and I guess Matt, whatever you want to do from here, Matt or John, yeah.
Well, thank you very much, Dr. Bowden. Yeah, I think you did an excellent job of not being just an evangelist, but showing a great overview of how fescue became a problem, the history of it, and then different ways we can manage around it. Burning questions? I'm sure there are a few. Yes, sir.
Has there ever been any testing on the genetics of the cattle? Which cattle do better on that fescue than others?
Yeah, I think they've done some. Mark probably can talk about it more than I can. I know there's been people who've said they got some data, but this seems to break down after a while. They always thought the Brahman cattle, if they had some Brahman in them, that they were used to the heat, and maybe that's what they were doing. They were better able to handle the heat in general than some of the European cattle.
What's your opinion of, we like diverse mixtures in our pasture.
Right.
Several varieties of grasses and legumes.
Right.
What's your opinion of mixing other grasses with the Max Q?
Sure, fine. I mean, it works well. The only thing I'm saying is that fescue component, it would be better. In other words, even if you have a 5-way mixture, especially in this country, I think what you're going to find is over time, even if you start off with equal amounts, probably fescue is going to become the dominant species. Now, I don't mean it's going to be 100%. It's probably going to be 50% or 40%, and the others will, 10%, 5%, and all this stuff. It's just that component, if it's toxic, you still have toxins out there. So it helps, and it definitely helps to have legumes in there, and that's a definite mitigation strategy. And if I'll just say, if you want to do that, that's fine. But if you want to get rid of or get the toxins out as much as you can, you're going to have to replace some of that fescue.
Do you have any experience with fesculoliums?
Very little. I've grown some of them, but I've never really grazed them or put them in pastures and stuff. They're again, I think they're fungus free, aren't they?
I think so.
Yeah, most of them are fungus free. I mean, they're dry grasses and. I mean, there's some good stuff out there. And like I said, I'd like, Chris definitely wants you to plant Max Q, and I'd like to see you plant Max Q, but if you think you can manage fungus free, I'm fine with that. We just need to be looking at trying to, a long-term strategy, and this is long-term. I mean, I understand that. But, and again, I know you're saying, well, that boy ain't got his money on the line. That's right. But, like I showed you in that picture for those prices, maybe you're leaving. In other words, you might be losing more money from fear of replacing your pasture than you're actually gaining. Yeah.
Has there been research done on how long a stand of that Max Q will last?
No, it's been around. We finally plowed up our pastures in Georgia. When McCann left, we just couldn't handle it, so we just finally plowed them up. But so we had some of them there 6, 7 years old, and there's been enough acreage planted. I mean, it's been hundreds of thousands of acres planted all through the thing, and as you can imagine, there's been variable results. Basically, the results have been positive. In other words, they've been able to retain stands for some people for a very long time. But like I tell you, there's people in Georgia that's got fungus-free stands that are 10, 15. So a lot of it gets back to management. Yes, Mark?
We've got a couple of fields there in Blackbird and the Mount Farm that would be between 10 and 12 years old.
Yeah. In this area, I would think that you could keep your Max Q in pretty good. It's when we get in these marginal areas, get out in western Arkansas, down around the coastal plain of Georgia and Alabama. When you start moving into those real stressful areas, then it becomes tough. It's even tough to grow toxic fescue down there and keep it for a length of time. So, but in this fescue belt, in that zone I showed you, you should be able to keep it pretty well with reasonable management. Yes, Bill?
Joe, we did, I think it's probably the same year that you're talking about, Mark, the Georgia 5 Jesup comparison. You're one of those trial sites with Tony Stratton. I think it was 2000, maybe it's 2003. But that stands still there.
Yeah.
So I mean, it's got some age to it now. I'm a little curious, when Matt was showing his data, and you had the particular slide, Matt, where you were looking at the variation and yet basic trends between the two different fertilized stands.
Yeah.
You had two red lines on there, and one was glitter, and one was fertilizer, and one was rotational grade, one was managed with some hay, if I recall right. But you both stands at the two opposite extreme ends of the season basically came back to the same point, which we found some consistency despite variation in location. Let's assume that we're all disciples today, Joe.
No,
We're rush home, we're going to sample 30 different pastures.
Y'all all been saved.
Yeah, absolutely. but let's assume there's not enough magic water to go around, and we're not going to replace all 30 pastures at the same time for financial reasons. So obviously what we would want to do is prioritize where the greatest need is based on the highest alkaloid level. My question is, if you sample all of them on day X, is the relative variation between pastures on your home farm going to be the same enough to make that assumption and then prioritize where you work on the worst problem? Or do you need to take multiple samples over a period of time to not draw an erroneous conclusion in terms of where your biggest problem is?
Again, I think Matt's got the best database, and I think, Matt, the question would be to you and John, how would you stratify these or prioritize these pastures based on what you've seen?
Let me ponder that a little bit. We've got more in the program. We've got a panel and things a little bit later on. Let me think about that a little bit, and I'll see if I can pull all my thoughts together.
I think one thing I would say, Bill, just to start things off later on, is from John and Matt's data, they're going to definitely, when they put the big trends together, the mega trends, they're going to show a timing of the year where they got the hottest things and a timing of the year where they got the lowest on the same pasture. Even though their lows are still pretty high. So I think what that does is at least narrows the sampling time for this region to where if you want to know when it's the best and when it's the worst, you make these two samples. And then, like I said, it's almost like your soil testing. I mean, really, we're talking about not doing anything different than y'all already do. You go out and you soil test different pastures, and then you fertilize based on the recommendations that you got. Well, finally, I'm hoping that one day there'll be enough information to where, you start saying, you get to these levels and it's like, well, you can do this, but it's going to cost you this amount of money. Or you're going to make this amount of money. I think that's where we really need to go in fescue research, in my opinion.
But based on what you're saying and what Matt showed, everything's above the threshold, so it really doesn't matter where we start.
Well, it appears to be, and again, I did a lot of hand waving here. I mixed some feeding trial data from Oregon with some grazing data from Georgia and kind of put them together. Y'all, it's like don't watch my hands, yeah. But yeah, I think the magnitude of the difference is so big right now that I think I could probably say that we're most of those samples will be above a threshold. I doubt if, from all I've read, I doubt if those thresholds, if you do a bunch of research, it's going to be 1,000. I think they're going to be in the hundreds, not in the thousands, but in the hundreds. Just where will y'all need to be, and because I know it's costly. So a farmer, but I want to get the discussion back to like you do for soil fertility or like you do for your feed reports and stuff. When you start getting these numbers, you need to start doing something about it. Either replacing if it's really bad, or I need to do some mitigation strategies here. I need to capitalize on some animal gain here because I know I'm going to lose it from the toxicosis.
Can we pass some of this information on to our friends at the Soil Conservation? If you talk to them now, all they want to talk about is fencing ponds, fencing streams. Mm-hmm. Why don't we offer another alternative to get the cows to naturally not want to go down there?
Well, I'm sure we can. It'd be good, And you know, SCS, once they get something done, I mean, NRCS now, you know, once they get onto something, they do a really good job. You know, but sometimes it's like turning the big freighter around in a small area. It's a federal program, and sometimes it's hard to get that changed. But that would be something, if any of y'all have any in into some of the NRCS programs, maybe give them that feedback, because that could be, yeah, yes.
I've got an insight on that from the NRCS.
There you go. There you go. I knew somebody be in the room.
And in fact, we're already moving that way. Basically, we've got the 512 forage and biomass planting practice. And within that, within our different scenarios this past year, starting in October 1st of 2014, so we just came into this new fiscal year, there's a certain one that's built into our payment schedule to, like when you have a rundown pasture system, if you want to renovate that, if it qualifies for that, then there is an option to plant a novel endophyte fescue in there.
I know there's a lot of legumes too. I know about that.
Yes, legumes, and also, you know, native warm seasons, but we figured that in for this program year, and there is a part of that payment schedule that addresses that. So it is an option, but you can't take a beautiful, productive, you know, endophyte infected sod and it has to come in and transfer or to renovate, to kill that and renovate. You know, just like any of our practices, they're put in place to where there's a resource concern. And that resource concern here specifically is if it's a rundown pasture situation that needs renovation, then that is an option.
So even though no-till, they wouldn't give a bogey for no-till?
No, you can do it no-till.
Yeah. So that beautiful pasture that's real toxic, you could no-till like I showed in
Oh,
this.
no.
Yeah.
No. You got a very good pasture. We're not going to pay for you to kill it and replant it.
What about killing 5 acres out of 20?
Is it a beautiful, productive pasture? No.
Like I said, it's turning that big freighter around in a very tight area. We might get it turned around one day.
Well, if we go in and just kill that 5 acres, y'all don't know it, and then we come to you.
Thank you very much.
One more final point to kind of tie in some things that I was thinking about as we move away from infection rate to really looking at ergot alkaloids. And some of the data that Matt and I collected showing that great variability. Have there been any studies to show any correlation between actual infection rate itself, say high infection, low infection, what the corresponding alkaloid levels are?
The whole thing is that infection rates don't change, but alkaloid levels do. So but there is at any moment in sampling, there's a very good correlation between infection level and alkaloid level. In other words, if you create a bunch of pastures that are 100% infected with toxic alkaloids, with toxic endophytes all the way down to 0 and have everything in between, your alkaloid levels will track it. The whole thing though is for that one static pasture, that alkaloid levels are moving up and down, and then especially you're concerned with is it really increasing over time, and I think that's why your alkaloids are what's causing the problem. There's no doubt that the endophyte infection is the root cause of the problem, but if you can't take alkaloids and you know your infection rate, you could probably assume that it's matching that infection rate pretty good, the alkaloid levels.
Any more questions? All right. We definitely will have further opportunities for questions. What we'll do now is we'll take a short, maybe 10, 15-minute break. And while we're doing that, my colleagues and I will pass out what we'll call a discussion prompter. I didn't include probably everything. Probably the main thing when I was listening to Dr. Bowden was maybe the pharmaceutical treatments for fescue. But basically to just kind of formulate an outline for later panel discussion on ways to mitigate toxicosis symptoms. So we'll go ahead and do that and then kind of get into discussion groups as we kind of prepare for our panel discussion. So as we do that, feel free to kind of look at your neighbors and figure out what on these points you'd like to ask questions on for our panel. And then we'll kind of move on from there. So go ahead and, have our break. If you need pencils, raise your hand. Make sure we get you.
Joe?
Yeah.
Thank you. That was good.
Hey, John.
Very much. The one thing I would like you to have shown in there, along with that hay ring and bringing seed in, a lot of our producers are not making hay at an appropriate time, which that bale bears testimony to, but then they're coming into a field, or they have the potential to come into a field that's covered with a hay bind that's covered with seed on it. So, but I was curious about your response to John in terms of correlation between infection and alkaloid levels. Because, presumably all these wild-type endophytes are producing alkaloids. But how much natural variation is there among those? So that's kind of the one I'm curious about. He's got 100% infected pasture, but it's been. I would think the selection pressures would be for much higher alkaloids.
It's definitely for higher infection.
Certainly for a higher infection, but also, not only infection. Infection only is going to take you so far.
If the alkaloids, I think what we really, there's so much we can do. In other words, how much is ergot alkaloids themselves contributing to this fitness? And if it's contributing to fitness, ecological fitness, then there's no doubt the ones that are remaining out there are probably the highest.
And that's so I've seen producers say they have problems, and they'll say, well, what's your site like? Well, it's kind of a droughty site, it's a southern exposure. I say, well, you probably selected for all the ones that are really thumping down here.
Well, you've got rid of that, because when the whole thing too is that I didn't mention it, but if I go and I sample, just get bags of seed, Kentucky 31, and I get them from different warehouses, they'll run anywhere from 0 to 50, 60%. The sweet spot's about 30. So I've sampled a lot of warehouses, but that 30% I planted, especially in stressful areas, within 2 or 3 years, it's 60-70%. Because the only thing living up is a toxic plant. So it's fit. I mean, it's Superman. And that's one reason we're not going to get rid of Superman. Some plants are imported into nature, but I think we just have to learn. But what I'd like you to do now is to grab all the like alcohol. That means a lot more than just the infection. Even though I know that certain things occur.